All right, in the last video, we talked about vision embedding, and we talked about, part of vision embeddings. We also talked about video encodings, video decoding, and we also dived into vision transformers. All right, all these things are very, very powerful concepts, and I can basically say that yes, you've learned quite a huge information that can help you particularly start solving real world problems in our world today with computer vision. All right. So in this particular video, we are going to be doing something quite germane and much more interesting, right? We are going to be talking about text to image generation. All right. Now we started with images, we started with videos. Now we are going the transformer way. We are now looking at how we can actually generate images, right, from text. All right. And in this video, I'll be talking about text encoding, of course, which scratched the surface in the last class. And I'll also be talking about vision encodings. These are the things that we've learned in the last class. We're going to be practicalizing it. We're going to be using text to generate some type of image contents. Stay tuned as I walk you through this.
Hello, welcome back to class. So in today's class, we're going to be looking at text to image generation. So we've been doing a lot of introduction to transformers, vision transformers, but let's talk about text. We've been talking about images and we've been talking about video. So let's talk about text to image. Is there any way by which we can actually convert a text to an image? So let's find out. All right, so in this video, we're going to be looking at text to image generation. We're going to be looking at how we can effectively execute text encoding. We're also going to look at how we can effectively execute image encoding. All right, so the reason why we call it text to image generation is that we have to do text encoding. So when you are trying to build a trained text data or a trained image data, you have to be able to encode the text that you are trying to train on and encode the images that you are trying to train on. Okay, and then put those data together and then train such that the model is able to see the relationship between text and the corresponding image. But luckily for us, there's a lot of pre-trained models, but we're going to find out in this particular video. So what exactly is text to image generation all about? Text to image generation in computer vision. So text to image generation refers to the task in computer vision and NLP, natural language processing, where a model generates a realistic image based on a given text description. I know I've not introduced you to text, but you might want to, of course, I would guide you on some of these things, but not so much, but at least give you an idea of what to do with respect to text. Now, this process is a combination of language understanding and image synthesis, where the model interprets natural language text and translates it into corresponding visual content. Okay, so it's a challenging problem that requires the model to bridge the gap between unstructured text and structured pixel level details of an image. So what are the basic concepts when it comes to text or image generation? Now, number one is text embedding, and that's where we are talking about how to encode or embed a text or something. Now, this deals with generating an image based on textual description. The first step involves converting an input text into a meaningful representation or a vector space. This is usually done by embedding the text using methods like word embeddings, e.g. word to vec, glove, or a transformer based model like BERT or GPT to capture the semantic meaning of the words. Now, recent models like CLIP, that is contrastive language image pre-training, or T5, that is text to text transfer transformer, are capable of better aligning text and image data. So in our next video, we're actually going to look at clips, but we're just literally trying to let us understand that these techniques like clip, they are very, very good at capturing the the representation of a text. All right. So sometimes we don't really need to worry about how to represent those texts. We can just leverage on the usage of this pre-trained model. Now, I want you to have understand that in all this, or everything I've been teaching so far, I've been laying emphasis on pre-trained models. Oh, they are pre-trained models and the likes. All right. So, but I want you to have an understanding that you can actually train these models on your own, and that's the reason why I actually had to give you guidance with respect to how you can actually train these models on your own. But nonetheless, for the purpose of reuse and demonstration, that's the reason why I'm exposing you to how you can actually leverage on the pre-trained models, and then of course with vast amount of data you can actually pre-train or train all these things on your own. Okay, so just pay attention to some of these things. So next is generative models. We've spoken about text embeddings. Next is generative model. Since we've need to embed the text, so now the question is, let's talk about how to generate how to convert that text into feed it into a generative model that now results into an image. So that's when we talk about generative adversarial networks, which we've been introduced to, or variational autoencoders. Now, I'm not sure I spoke about variation. Yeah, I don't think I've taught about variational autoencoders, but I will want you to take a look at it. So GANs or variational autoencoders are often used in text-to-image generation. Now, these models generate images from random noise. This model generates images from random noise, but when conditioned on textual input, they learn to generate images that match the text description. Okay, now let's take a look at GAN-based text-to-image model. An example of such GAN is stack GAN. Now, this model uses a two-stage GAN, where the first stage generates a low-resolution image and the second stage refines it to a high-resolution, conditioned on some text description. We also have, I've demonstrated this in our previous class. We also have some other type of GANs, like attention GAN. Attention generative adversarial networks focus on the importance of specific word in the text and apply attention mechanism to improve the quality of the generated image. Alright, then we also have VQVAEs, that is vector quantized variational autoencoders. Now, this model has been used in generating high quality images from text by learning discrete representation of images and text. We also, now let's we've studied the second part, which is generative model. The first one was text embedding, second was generative model, the third is discriminators and adversarial learning. So in GANs there are two components, that is the generator and discriminator, which we've learned. The generator creates images based on text description. The discriminator evaluates whether the generated image matches the text description. So all these things gives us a clue on how to effectively build computer vision systems, or build a visual data from text. If you can actually solve the problem of text to images, then you can actually convert it into a loop whereby you generate text, convert videos into text. Okay, that is convert video data into text, so, or text to videos. All right, so we understand what discriminators and adversarial learning is all about. Now, adversarial nature of GANs helps improve the quality of the generated image, as the generator tries to fool the discriminator and the discriminator tries to accurately assess the generated image. All this we've learned them from our previous text or previous classes, but I'm just trying to re-emphasize them because these are some of the concepts or some of the key points that you need to be aware of when you are trying to implement a text to image generation system. 4 is the conditioning on the text. In text to image generation, the model is conditioned on text, meaning input text description influences the image generation process. This is usually achieved by concatenating or combining the text representation with the latent vector of the generator's network, thereby guiding the generation process. When we are doing GANs, the GAN that we did, it was just generating random image because it has been trained to see, it knows how cats look like or dogs look like, but there was no condition. So this is a typical type of a conditional GAN whereby it's conditioned with respect to the text. So what allows the generation to be well informed on what to properly generate is due to the text representation, that is the vector space of the text. That is because you have to convert the text into numerics, which is the vector space representation of that particular text, with the latent vector in the generator's network, thereby guiding the generation process. Alright. Then you also need to take note of what we call cross-modal embedding. The challenge in text-to-image generation lies in aligning visual and textual data, which may have different structures. That is, images are visual data and text is definitely linguistic. So models like CLIP, which I'll talk about in the next video, that is contrastive language image pre-training, uses shared embedding space where both images and text are mapped to a common feature space. Thereby, this allows the model to relate specific aspect of the text with the visual feature of the generated image. So that is how images, are being guided into generating what the text is illustrating. So it's a very, very deep level of training or pre-trained model. So popular models for text image generation, we've spoken about GANs. That is, we have stack GANs, two-stage GAN architecture that progressively refines the image. The first stage generates a low resolution image from the text, and the second stage improves it into a higher resolution. So we also have attention GAN. This uses attention mechanism to focus on different parts of the input text and generates more detailed and accurate image based on the text. We also have big types of GAN, or large scale type of GANs. So I target big GANs. So a large scale GAN model that can generate high quality images, and when combined with text features can create diverse image based on text prompts. So we have generative lattice GANs. We also have deep denoising score matching. So DDIM based models can actually generate high quality images by gradually denoising from random noise conditioned on the text. So this model provides a flexible way to create images using language. So you might want to check out more about DDIM. You can also take a look at, of course, CLIP with VQ VAE. CLIP was developed by OpenAI. I'll talk more about that in the coming video. So it's a model trained to understand images and text together. So it uses a contrastive learning approach where text and images are encoded into a shared space. Combining this with VQ VAE allows for more realistic image generation from textual description by aligning image and text representation. We also have DAL-E. DAL-E was developed by OpenAI. So it's a model specifically designed for generating images from textual description. It leverages a transformer architecture similar to GPT-3 to generate coherent images from even abstract or creative text inputs, such as an avocado chair or an armchair in the shape of an avocado. We also have DeepMind's image transformer. So image transformer is another model that uses a transformer architecture to generate high quality images from text, focusing on both local and global structure generation. If you remember, I in the last video I talked about timesformers, vision transformer. So in this case, when we are saying image transformer, we are basically referring to vision transformers and the likes. So literally, these are typical models that can be used to actually generate images based on text prompts. So what are the different applications or where can you apply text to image generation? What are the different areas where you can actually apply text to image generation. Now, text image generation is applicable in the creative industry, and that's the graphic design, for instance. So text image models can help designers generate concepts, art, illustrations, and visual content directly from textual description, significantly speeding up creative workflows. Then it is also applicable in advertising and marketing. So let's say you want to generate custom visual based on product description, which can help marketers create unique content for campaigns. It is also applicable in e-commerce, that is product generation. E-commerce platforms can use text to image generation to create product visuals based on a simple textual description of the product, thereby allowing customers to visualize items that might not exist physically yet. So it's very, very applicable to e-commerce. It is also applicable in the space of virtual reality, AR, and VR. Okay, when we're talking about immersive environments, so text to image generation can play a role in creating virtual environments or assets for VR, AR experiences based on user inputs. It's also applicable in art creation. AI generated art is becoming more popular, while artists or non-artists can use text prompt to create artworks using models like DALL-E or attention GANs. And so let's talk about accessibility. Description generation for people with visual impairment, it's applicable in that aspect. So text to image models can help generate visual description of scenes or objects in real time, providing a richer experience. So I'll say accessibility. So basically for description generation, visual impairment, and the likes. All right. So what are the challenges in text to image generation? Number one, semantic understanding. The system needs to deeply understand the semantic meaning of the text to ensure that the generated image aligns well with the text. So that's one of the reasons why we use pre-trained models, because to build such kind of model that has such deep meaning and the likes, it requires a lot of semantic understanding. Then detail generation. Generating fine details in the image from text description remains a challenge. Some text prompts may require more attention to finer aspects like texture, lighting, and spatial relationship. If you notice, sometimes generation of images can still be quite challenging because of the details. It requires more attention with respect to texture, lighting, and the spatial relationship, so as to illustrate what is being said in the text. But of course, the field is evolving and things are getting better with time, with respect to time. Then another challenge is generalization. While models like DALL-E show impressive results generating images from highly abstract or unconventional description, can still pose difficulties, or highly abstract or unconventional, it can still pose difficulty. So sometimes, if you notice that when you are using DALL-E or OpenAI or something, it's the kind of images it generates, they are not, they are from certain type of concept, which is based on the type of model and the data it was trained on. So sometimes, if you want it to if you want to make it model some very, very real Nigerian space or something, it might not be able to generalize as much, but it might be able to get a picture what it could look like, but not exactly. So it still has a problem of generation, and of course things are getting better within the space. Alright, so let's dive deep into the hands-on aspect of this work. So first and foremost, I want you to open your notebook, the collab notebook, and let's dive hands-on. So first, I would want to be working with some packages. So I'll be doing this on Google Colab, Literally, most of the things I'll be talking about or sharing is you can find them in the transformer documentation. I'll try and pinpoint that after the so one of the first things I want us to be able to try out is to actually generate images from text using some pre-trained models. Let's say like Stable Diffusion, DALL-E, OpenAI, or Google Image Gene. So we are going to be using, of course, Hugging Face, the Transformers Hugging Face. But there are some packages that I want us to install first. Let's confirm if our runtime is in place. Let's change runtime. Okay, we have GPU, so that's great. So pip3 install diffusers. I'm gonna talk a little bit about that, of course. Then transformers, touch, accelerate, and then safe tensors. So now with some of these packages, installation, building some of or text to image becomes very easy. So the diffusers package gives us access to models from Stable Diffusion and some others like that. So let's try out text to image generation using Stable Diffusion or the diffusers. So import touch, then I want to say from diffusers, so import Stable Diffusion pipeline. Alright, so let's go import touch. So first and foremost, let's load a pre-trained model from the Stable Diffusion pipeline. So we're going to be using this particular model ID run wayml / Stable Diffusion v15. Alright, so the pipeline is simply Stable Diffusion pipeline dot from pre-trained. So this is how you get pre-trained models. So let's just try and see if we can actually generate. So in this case, this is the prompt. So we are moving into CUDA. Then this is the prompt. So let's just say a photo of an astronaut riding a horse on Mars, for instance, or better still, let's say a cat and dog smiling at each other, for instance. I know we've been doing a lot of cat and dog kind of experimentation. So let's generate the image. So the generated image can then be pipe prompts dot images. So let's save the image. So image dot save generated img.png. So let's run this and then let's picture what this is gonna look like. So simple codes like this gives us a clear demonstration of how you can actually prompt models like the Stable Diffusion models. So these are typical prompts. You can actually try it out, try and generate. Okay, so this would require your Hugging Face token. So you can basically see it's requesting access to my Hugging Face token, which I've added to my secret key. So I'm just going to give it access. So it's downloading the models, fetching quite a lot of files. You can basically see this is about 2 gigabytes, this 500 MB, this is about 1 gigabyte. That is vocab, that's the tokenization. So it's literally downloading quite a lot of models and the likes. But sometimes this kind of things takes time actually, but not so much of the time. It's not so much of time. So I'm just waiting to see the generated results. So there are other platforms. The other platforms, this DALL-E, we just prompted the DALL-E and we told it to generate this image. There's OpenAI, these diffusers, this stable diffusion. There's OpenAI DALL-E developed by OpenAI that you can also prompt and then tell it to develop this, develop that, and So let's take a look at this. So I think the generated image is now. So let's download so that we can take a look at the image we just generated. So we said a cat and dog smiling at each other. So let's take a look at it. This is quite fun though. So this is a dog and this is the cat. Well, this cat actually seems like it's frowning at the dog, but we said it should generate, and you can basically see it kind of looks very real. But of course, we both know that this is not. This is AI generated, definitely. So there are quite a number of other processes, other ways, other things that you can also do with respect to text to image generation. Alright, so that's that with respect to stable diffusion. So another I would love to introduce you to is let's say OpenAI. So these are some of these models that we outlined that we're just trying out. There's a lot of them actually. So let's try out AI DALL-E model. Alright, so of course, definitely to use it you have to do pip install OpenAI. Yeah, I hope I got the installation. Alright, so I believe OpenAI is actually installed. So it's quite a straightforward. Of course, you're also going to have your OpenAI key embedded in Google Colab. In your secret key tab, you need to have. So I literally have OpenAI key, Authorities key, Cargo key, Google API, Maps, quite a number of keys. So you can also have yours like that embedded. Alright, so for OpenAI, it's quite simple and straightforward. So import OpenAI, and then so from google.colabs, because I wanted to use my OpenAI key, user data, OpenAI key, get my OpenAI key. So I want you to generate a response by prompting OpenAI to actually create. So let's try and see, let's give it the same prompt just as we have with DALL-E, a cat and dog smiling at each other. So let's give it the same prompt and let's see what this is able to generate for us. So this sends the prompt to OpenAI. Secret OpenAI key does not exist. Okay, open. So you can just copy that. Alright, so let's run that. So I'm gonna grant it access to all of that. Okay, so I think okay, let me be emphatic with respect to this particular version, just for the sake of this demo. You might want to look into, I'm kind of used to this style of okay, let's restart session, at least for the sake of so let's run it. So let's see what OpenAI generates for us. Let's see. So we can actually compare that with then another I would love to. Okay, so it's going to return us an image URL. So we can actually click on the image URL. So let's copy it and let's go check it out. Okay, so this is what OpenAI kind of generated. Quite hilarious though. Very, very, compared to what our diffusion model generated. So this was this. So it's quite interesting that this AI can actually generate some of all these things. So one more thing before we round it off, I want to also introduce you to stable diffusion extra large. So I want us to use one of the models. Code text. Okay, so let me call it stable diffusion XL. So it's the same thing as what we have here, but this kind of diffusion model it generates high resolution. So I just want us to try it out, and but the only difference I'm going to be putting here is just changing the model ID. But let's try from stability a high, stable diffusion XL. Let me use XL base 1.0, 1.0. Then of course for pre-trained model, cat and dog smiling at each other, generated XL. So let's see what we find with respect to this. So literally what we just had to try out is the stable. So there are different model IDs that you can actually try out. So you might just want to take a look at the diffusers package and of course the model ID. So take a look, so check the reference for most of these links to the diffusers package, documentation about some of all these things, stability.ai, stability AI. They are doing a lot of very, very awesome things. You can also check out their developers platform. Let me just so you might want to check out some of their work, some of the things that they've done, and of course go ahead to check out documentation. And then of course with documentation you can actually generate stable images. You can also generate videos. So some of the documentations you can check out on Google Colab, which gives you a guide on how to use them. Learn more about REST, and they also have a REST API documentation also that you can also check out or try out. So you can basically make API calls to their API. Let's say you are building a software and you just want to so literally there's a lot of support guides and the likes with respect to using these platforms. Alright, of course you can generate stable videos also, but of course by prompting and calling their APIs, and so many other things like that. So while we're waiting for this is almost done. Then diffusers, please take a lot more time to study transformers, this Hugging Face transformer package. It's quite detailed and quite very needful and can be very, very helpful with respect to understanding a lot of these concepts. Okay, so argument non-type is not iterable. So that means you have disabled the safety check for blah 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 by passing safe checker. Sure you abide by the condition. both the diffuser steam and blah blah blah. This is long. All right, so let's take a look at why we have prompt images, pipe to CUDA, stable diffusion pipeline. Okay, maybe we should run it again then. I guess there was an error somewhere, so let's just give it some time. All right, so let's give it some time to run. So so while we were trying to run, we ran out of memory, so code out of memory. So one out of two things we can do is to rewrite the code to work for this particular CUDA, or we move it into a new GPU box. So you could actually spin up a run pod and run the code, and you're still going to get the same result. But what other thing can we do? So I had to import from diffusers import. We already have this, so I want to use auto pipeline for text. So what I'm just going to do is I'm just going to take this and then replace it with auto pipeline for text, and we're going to rerun this. So once we rerun, so let's see what we have. So stable diffusion extra large. So I also want to introduce you to diffusers. So let's check diffusers, fuser, transformer Python, these diffusers. So if you look at pip install diffusers that we're doing, so there are a lot of documentation, tutorials with respect to diffusers and how to use it. So we have text to image here, so you might want to try out some of their text to image from diffusers, which is the same thing that I just tried out, import touch, and then it should be able to generate. Then we also have image to image. All right, so you might want to try out some of the image to image processes. Okay, there's in painting. You might also want to try out text or image to video, so text to video or text to image. All right, so this is called video hex, used for 3D variational autoencoders. So you might want to check it out. So you could basically see this is the initial image, and it became this video. So stable diffusion video. So you might want to check it out, and so many other things. All right, so let's go back and check out our code, and let's see. I think we have an error. Okay, let's run it again. Okay, so literally we're not working with stable diffusion pipeline anymore, so we can just use auto pipeline for text transformer. So let's see what we have. Okay, I think I duplicated it here, so just gonna delete this so as not to confuse you. Okay, so the secret doesn't exist in your collab secret to authenticate. Yep. Think I need to do that. I think I need to have my HF token, but let's see. So I decided, so I ran out of kernel because I wanted to demonstrate from collab, so I switched to a new Google account. So but my HF token isn't on this new Google account, so I'm just going to go ahead, connect it up, and then yep. So we have our results. So let's take a look at it. So Let's download and let's take a look at it with respect to other what they call it, other images that we've downloaded. So this is quite hilarious though. So this is an image of cat and dog laughing at each other. Okay, this is the one that was generated before that. Cat and dog, though it doesn't look so, because this mouth side looks somehow. All right, so I believe we've been able to see the difference, but actually this extra large seems better than this, even though that this teeth thing looks extra weird. Okay, I know that dogs have this teeth thing, but this one looks too extra. All right, so basically I'd love to advise try out a lot of stable diffusion codes, text to image, try out these diffusers, scroll through specific pipeline examples like stable diffusion Excel, cog videos, control nets, texture inversions, LoRa, stable vision diffusion. Okay, so this is what I'm talking about. So looking at all this sidebar, so just take a look at some of them. LoRa, trajectory consistent distillation, LoRa. Okay, you might want to check out some of the paperworks and whatever that is behind some of them. Peeping stuff, PEFT for better LoRa support. So check out some of this code. So they are quite straightforward, just for you to play around with. All right. So your assignment, I want you to just try out. So basically, your assignment right now is to actually try out and study more about some of all these things, so that you can have better understanding of how to use all these pre-trained models to solve problems. And I look forward to seeing you in the next class.
Congratulations, I want to see that you've done quite so well sitting this long to comprehend everything I've shared with you with respect to how you can generate images from text data. We talked about text encodings, which is a part of NLP. We also talked about vision encodings, that is the video itself or the image, right? I want to see that yes, you're doing so well. Alright, so there's going to be an assessment of everything that you've learned in today's class. Don't forget, everything that we've been learning gets bigger, better, and brighter. Okay, so there's going to be an assessment just to evaluate everything you've learned in today's class. So I look forward to seeing your response, seeing your results. This is going to be shared via Google Classroom. Follow the instruction that I've provided for you. Alright, make use of the breakdowns, and make sure that if you have questions, do not hesitate to reach out. Alright, I look forward to seeing your solution, I look forward to seeing your results, and I definitely look forward to seeing you in the next class.